Thank you, Brad, for the kind introduction. And thank you to the National Energy Policy Institute and the University of Tulsa for inviting me here. It's quite an honor to be here. My talk today is on an empirical dynamic model of OPEC and non-OPEC. OPEC and OPEC strategy have long interested and puzzled economists. It is clear that OPEC wields much power over the world oil market and that OPEC producers behave strategically. But what exactly is OPEC's strategy, and is it possible to model it? The research I'll be presenting to you today is the first cut at a long-term research project focused on analyzing and understanding OPEC and OPEC behavior. The particular research questions I address today are, have OPEC producers colluded? Do non-OPEC producers have market power? And what is the shadow price of oil? The methodology I use is to estimate an empirical dynamic model of the world oil market. And I use this model to test for market power and collusion. This research makes several important contributions to the literature. The first contribution is that it's an empirical estimation of Hotelling's theoretical model of non-renewable resource extraction. So this paper follows up very nicely on the discussion we had this morning with Professor Kaufman, Dr. Green, and Professor Brown on the Hotelling model. So I tried to devise an empirical model to estimate the Hotelling model, so based on the Hotelling theory. A second important contribution of this paper is that I address the identification problem that arises when you try to identify supply equations. So when you try to estimate a supply equation, there's an endogeneity problem, which is that price is endogenous because supply and demand is endogenously determined. And because of that, we need instruments to address for the endogeneity problem. And so I use instruments in this particular model to address the endogeneity problem that arises in estimating supply. A third contribution is that it's a dynamic model of market power. So there has been an extensive literature on testing market power in the world oil market that is using a static framework. However, oil is a non-renewable resource, and because of that, extraction today affects how much you have available to extract tomorrow and the cost of extraction tomorrow. And as a consequence, we need a dynamic framework to analyze the optimal extraction of oil. And so I incorporate a dynamic model with the literature on market power tests, in order to test for market power for the world oil market. Another contribution is that I make minimal functional form assumptions. So there are not many functional form assumptions I make in estimating my model. So one problem that plagues a lot of empirical estimations of the world oil market is that you have to make ad hoc assumptions about certain functions. And I try to design a test that doesn't involve very many functional form assumptions. So it's robust to whatever functional form you think the supply and demand actually takes in the world market. And the final contribution is that I estimate the shadow price for oil. As you recall from this morning's discussion, there's sort of a controversy of whether or not there is a shadow price. Here I try to see whether or not we can have a shadow price as well as potential market power in the world oil market. And what is the shadow price? Well, the shadow price measures the value of a unit of a reserve in the ground. It reflects the scarcity of reserve. It's it's an economic measure of scarcity. And it's an indicator for how sustainable the resource is. And it's the single best index of trends in resource scarcity. So now I'll proceed to talking about my model. So the variables in my model are the following. Little qj of t is the quantity supplied by producer J at time t. Big Q is the total quantity supplied, so it's the sum over all J's of the little qj's. S of t is the stock of oil at time t, so it's the amount of oil that's available in the ground. capital P of T is the market price of oil, and little p of T is the shadow price of oil. So the functions I have are the following. So as I mentioned, I make very little functional form assumptions, so I just have them sort of generally, demand is generally a function of price, and market's clear so that the amount that's produced, which is our big Q, is equal to the demand of oil as a function of price at every time T. And cost, I assume cost is a function potentially of stock, so there are potential stock effects in oil production. So stock effects arise if the marginal cost of producing oil rises when there's less oil remaining in the ground. So there's potential stock effects in oil, so I allow for that. And then the cost of oil also depends on how much you produce Q, as well as potentially on time T. So again, these are, I'm just allowing them to be general functions of these variables. So the optimal control problem faced by an oil producer is to maximize the present discounted value of the entire stream of per period payoffs subject to some constraints. So we have the constraint, which is the equation of motion, which is that the stock evolves as the stock decreases as you extract oil from it. And associated with that equation of motion is the shadow price little p, which is the hoteling rent. And then we have the constraint that you have to produce a non-negative amount, so Q is greater than or equal to 0. We have the constraint that the stock has to be greater, the stock remaining in the ground has to be greater than or equal to 0. And then we have an initial condition for the amount of stock that's initially available. So the producer is choosing the entire time path of production so as to maximize the present discount value of their stream of per period payoffs. So the per period payoffs vary depending on what the market structure is. So if we have perfect competition, the per period payoffs pi are total benefits, U as a function of Q and T minus total cost, which is the cost function. So it turns out that the solution to a perfectly competitive markets problem is the same solution as that of a social planner's problem. So you can model perfect competition by saying that they act as if their per period payoffs are total benefits minus total costs, which is what the social planner would do. And that's because when you take the first order condition, it turns out when you take the first order condition of total benefits, it's going to be the same as the first order condition if you have just price versus quantity where they're price takers. So that's how I model the per period benefits for perfect competition. If we have perfect collusion so that the actors within OPEC behave as a monopoly, then the per period benefits are going to be the profits, which are the price, which is given by the inverse demand curve. So if they're behaving as a perfectly cooperating monopoly, then they will be able to influence the price through their choice of quantity. So the price is going to be given by the inverse demand curve. So the revenue is that price times quantity, and then you subtract from it the cost. So for the monopoly, it's going to be price times the quantity that the monopoly produces minus the cost over all the producers in the monopoly, or in the perfectly colluding monopoly. Whoops. And then for the Cournot oligopoly, if there's market power but the producers aren't behaving as a perfectly collusive monopoly, then the per period payoff is, again, profits, which is revenue minus cost. But this time, the revenue is going to be the price is given by the inverse demand curve times the particular quantity produced by the particular Cournot oligopolist minus the cost faced by that particular Cournot oligopolist. So using the maximum principle, we have 3 first-order conditions. And the first-order condition varies depending on what market structure we have. So under perfect competition, the first-order condition is that price equals marginal cost plus the marginal user cost, which is the shadow price. So that's what happens in a perfectly competitive market. And as Professor Kaufman rightly observed, even with a perfect competition in a dynamic, because we have a non-renewable resource, the price can exceed marginal cost, and that's because of the marginal user cost, even in the absence of market power. So this is what happens in perfect competition. Under collusion, we have price equals the markup plus marginal cost plus the marginal user cost. So there's also a markup term that arises under a monopoly or under collusion. And then we also have a markup as well if we have Cournot oligopoly. So again, price is equal to markup plus marginal cost plus the marginal user cost, or the shadow price. And the markup varies a little differently depending on if you're in the a perfectly collusive regime or if you're in a Cournot oligopoly. And then the second first-order condition governs the it's an equation of motion for the shadow price, P, or the marginal user cost. And one interesting thing to note is that if there are no stock effects, so if the partial of the cost function with respect to the stock S is equal to 0, meaning that the cost of production does not depend on how much oil there is in the ground, then in the absence of these stock effects, then the shadow price should rise at the rate of interest, and this is the hoteling rule. However, this is not necessarily the case, as was observed by some people, in particularly Dr. Green, in the morning session. So this is, the shadow price doesn't necessarily increase over time, and this is because there could be stock effects. So if the cost of production depends on how much stock there is in the ground, then the shadow price might not necessarily rise at the rate of interest. And there are multiple reasons why. So if the price rises at the rate of interest, this is purely measuring the scarcity, but it can also be offset by technology. So I allow for, in two specifications, I allow for the shadow price to evolve either at the rate of interest, assuming there are no stock effects, and then I have a model where I allow for stock effects and allow the shadow price to evolve more flexibly. And then the third condition is a transversality condition. So up on the top, I've rewritten the three first-order conditions, the first-order conditions for the three market structure scenarios. And from these three first-order conditions, I derived a general supply-side first-order condition, which is an amalgam of all three of them, and allows me to test among the three different first-order conditions. So the test is the following. So in the first line, so we have if theta 1, the first line, so the line here corresponds to non-OPEC producers. So if this theta 1 here is equal to 0, so this term is not significant, and then the second term will not apply to non-OPEC producers because it's only multiplied by an indicator for OPEC producers, then if this theta 1 is 0, then the supply side first order condition collapses to price equals marginal cost from plus shadow price. So this is exactly the first order condition for perfect competition. So if theta 1 is equal to 0, we have that the result that the non-OPEC producers are perfectly competitive price takers. If theta 1 is equal to 1, on the other hand, so that this first term becomes significant, then the price is equal to markup plus marginal cost plus the marginal user cost, and then we have this Cournot oligopoly. Basically, we have this third first order condition over here. So this model collapses to the non-OPEC producers being Cournot oligopolists. And then if theta 1 is between 0 and 1, then the non-OPEC producers have an intermediate degree of market power. So they're not perfectly competitive, but they're also not perfect Cournot oligopolists, but they do have some market power. So, so this is regarding the first line regarding the non-OPEC countries. And then the second line, theta 2, this second line is hit by the indicator for being an OPEC country. So this second line applies if we're talking about an OPEC country. So if theta 2 is equal to 1, so if this theta 2 is equal to 1, then we have price is equal to markup for the OPEC plus marginal cost plus marginal user cost. So the OPEC producers are colluding, so they're behaving as a monopolist if theta 2 is equal to 1.